Good day, guys. Welcome back to part 3 of the video tutorial for assignment 8. In part 3, we're going to focus on conducting a slope analysis, which is good to showing areas that have high gradient, areas that have flat gradient, and this will also enable you to answer particularly question 3, which is asking about identifying areas for suitable informal settlement upgrading. So in this part, I'm going to show you how to do the slope analysis. So you can actually switch off your DM layer because that will not be necessary. You can actually switch off contours and minimize those as well. So to do the actual slope analysis, come to your Alt toolbox. Obviously come to under spatial analysis tools, under surface, then come to where it says slope. Double click on the tool, wait for it to appear. Now input raster obviously be a Gauteng DEM, and then we have actually two output measures. So you can actually calculate slope in terms of degrees, or you actually can calculate slope in terms of rise. Whichever one is okay. So degrees or percent rise, anyone is okay, whichever one that you find to be comfortable. Sometimes people so most likely will use degrees because it's easier to almost visualize and picture. Go back to old mathematics in terms of one of the mathematical sets that we used was a protractor, and on that we had actual degrees in terms of going from 0, 20, 30, 40 and so on. So that would be easier to visualize if it's within degrees. So you can use degrees. Then our output raster, we can save it as Gauteng underscore slope. So here's typo there. Gauteng underscore slope, then underscore degree. Okay, let's bring it across there. Upper raster length of the grid. Okay, so basically it's saying that the length is too long, so let's need to shorten up the name. Dig. Let me see Gauteng underscore dig. So basically it's saying that names is too long. Let's see if it appear. Yeah, no, that's fine. Okay, let's wait for it to process, and then from here we're able to see areas that have a steep gradient. So as you can see, green areas basically show areas that have a very stable gradient, very flat. And then while red areas show areas that have a high degree in terms of, as you can see, from 23 to 40 degrees. They have quite a high gradient, as you can see in the particular northern parts of Gauteng. Let me just switch on my Johannesburg. After around Johannesburg or so, moving a bit to the northwest of Johannesburg. So then, yeah, if you zoom in, you can just see in terms of areas that have high gradient steeps. So these are particularly your mountainous areas, in a sense. So then, obviously, when you want to do informal settlement upgrading, you obviously want to do it particularly on flat surface areas, because it's easier in terms of implementing infrastructure, whether particularly for your underground infrastructure, your sub-infrastructure, your water and sewage, and even your electricity grids and transformers. So obviously when you want to identify areas for informal settlement upgrading, look for particular areas in the green. So obviously these have a flat surface, and obviously informal settlement upgrading will be most applicable in these areas. So that actually concludes question 2 in a sense, because from there you create a high quality of map of the contours which you have there, and you create a high quality map of the slope in Gauteng. Then obviously question 3 is asked to provide a description of the slope in Gauteng, identify areas for suitable informal settlement upgrading. So from there you can provide a description in terms of the actual degrees. So what I can recommend to make it easier in terms of providing a description, I think maybe put in your municipality shape files under your auxiliary data. Let's just put it there. Off the hotspot hook, it's okay. And then let's make this let's first make it parent. So hello, then labels. For labels featured up here because it's for all the municipalities. Labels feature. Let's see. I don't know what under. Let's just say okay. And let's actually open up the attribute table to see where the municipality names are appearing. Oh, it's already appearing. So it actually appears under S12 name. So you can actually use that layer. S12 name. So as you can see, Ukrainian Metropolitan Municipality, Johannesburg, Restaurant. So from there you can actually provide an accurate description in terms of, particularly on the north boundary of the West Rand municipality, that's where you have high gradients, slopes, in terms of 3620 right across the interior. Yeah, so then at least I can give you a better description in regards to when you have to describe areas for that are suitable for human setup upgrading, and yeah, and so on. So yeah, so that actually concludes question 3 and question 3. So essentially we've also provided actual methodology part in terms of completing question 4, because it says based on DM create a slope analysis and create a map that depicts high risk areas for flooding, landslides, earthquakes, and earthquakes in Johannesburg. So I don't know about that earthquakes one, but okay. Let me just switch that off in Johannesburg. So what you're gonna do in your next, obviously to create your next 2 maps, you're obviously gonna take your Gauteng DM and you're gonna actually mask it to Johannesburg. And you're gonna carry out that whole contour process in terms of slope and finding areas that are particular susceptible to landslides. So with that, with part 3 done, I'm actually going to move on to part 4 in terms of now actually identifying areas that are risk of flooding, landslides, and earthquakes. I'm not sure about the earthquakes one; that's a bit tricky. But we'll probably focus on flooding and landslides, and we'll see what you can do for earthquakes. So in part 4, we're going to look at that, and I'm actually going to use a new one of the ArcMap software suite of ArcScene. And just as a bonus clip, I'm going to show how we can actually simulate flooding. So we're basically simulating which areas would be at most risk to flooding and particularly in Johannesburg. So this concludes part 3. Or was it part 4?